Welcome to our video tutorial on operating systems. In this video we cover what is an interrupt, types of interrupts, the interrupt handling process, important applications of interrupts. An interrupt is a signal generated by either hardware device or a software component to interrupt the normal execution of a program and request immediate attention from the operating system. This mechanism allows device and software to communicate with the operating system and notify it about the specific event or the request without continuously polling or waiting for a reason. This is the mechanism of the interrupt. When an interrupt occurs, it causes the process to suspend the current program execution and transfer the control to a specific interrupt handler or interrupt service routine as shown in the diagram above. Here different devices are there which can generate an interrupt via controllers. This is disk controller, mouse, printer, keyboard, which are USB controllers, and the monitor, which is a graphic adapter. These all goes into the memory. The interrupters in the operating system. Basic concepts and importance of interrupters in operating system. Interrupts are crucial in operating system because they allows the system to respond to event as they occur rather than relying on the continuous polling of the state of the device. The mechanism enhances the efficiency and responsiveness of the system enabling it to handle multiple tasks concurrently. The importance of the interrupts. Efficiency. They eliminate the need of the CPU to waste time on polling. Responsiveness. They ensure timely processing of events such as user input or hardware signals. Multitasking. They allow operating system to manage multiple processings effectively. The difference between hardware and software interrupters. A computer system is divided into two categories, hardware and software. Hardware refers to a physical and visible components of the system such as a monitor, CPU, keyboard and mouse. Software, on the other hand, refers to a set of instructions which enables the hardware to perform a specific set of tasks. The software must be installed in the hardware to function properly. And similarly, the hardware must be present for the task to be performed. Both are interdependent yet they are also different from each other. Coming to the software, examples of the software are Google Chrome, affected by viruses, intangible, etc. Coming to the hardware, they are laptop, tangible. These two are affected by the wear and tear. The software components are affected by the virus and the hardware are affected by wear and tear. The difference between hardware and software interrupts. Hardware interrupts. Hardware interrupt is an interrupt generated from an external device or hardware. Coming to the software interrupts. Software interrupt is the interrupt that is generated by an internal system of the computer. The hardware interrupt do not increment the programming counter, but the software interrupt increases the programming counter. Hardware interrupt can be invoked with some external devices such as request to start an IO or, a, or an occurrence of a hardware failure. Software interrupt can be invoked with the help of INT instructions. The hardware interrupt is the lowest priority than a software interrupt. The software interrupt is high priority among all the interrupts. A hardware interrupt is triggered by external hardware and is considered one of the ways of communicating with the outside peripheral hardwares. Software interrupt is triggered by the software and considered one of the way to communicate with the inner or triggered system calls, especially during the error or exception handling. The hardware interrupt is an synchronous event. The software is an synchronous event. The hardware interrupts can be classified into two types. They are maskable interrupts and the non-maskable interrupts. The software interrupts can be classified into two types. They are normal interrupts and the second one is exceptions. Keystroke, depression and mouse movements are the example of hardware interruption. All system calls are example of software interruptions. The types of interrupts: hardware interrupt, software interrupt, maskable and non-maskable interrupts, exceptions. This is the picture of the types of interruptions: hardware interruption, software interruption, IO interruption, time interruptions. Coming to the hardware interruption are generated by external hardware devices to communicate with the operating system. These interruption indicate specific event or the condition of the required attention from the system. Examples of the hardware interruptions are time timer interruption and the IO interruption. The timer interruption are generated by a system time or the clock to indicate the expiration of a specific time interval. Time interruption are commonly used for scheduling tasks, measuring time intervals, and triggering the periodic events. The IO interruption are generated by input and output devices such as keyboards, mics, mouse, disk controllers, or network interface cards to indicate the completion of an operation or a request for attention. For instance, when a key is pressed on a keyboard, an interrupt is generated to notify that operating system. In the multitasking operating system, a time interrupt may be set to occur every 10 milliseconds. When it expires, an interrupt is generated and the OS scheduler takes control to the switch between different running processes. Software interrupts. Software interrupts are also known as software exceptions are generated by software components to communicate with the operating system or trigger specific action. Examples of the software interrupts includes system calling expectations. A system calling is generated by a software program to request a specific function provided by the operating system. System calling enables user-level applications to interact with privileged operating system functions such as file operations. Expressions. These are generated by a process in response to exceptional conditions or events. Examples of exceptions includes division by zero, invalid memory access, or illegal instruction. A user program wants to read the data from a file. It invokes a system calling to request the operating system to perform the file and read the operation on its behalf. It is a system call. This is a scenario for the software interruption. Maskable and non-maskable interruptions. Maskable interruptions. These can be turned off or ignored by setting a bit in an interrupt mask registration. Example include standard hardware interruption like this from input and output devices. The CPU is in there is a mask between CPU and interrupt controller or hold. Non-maskable interrupter. These can be ignored and must be processed immediately. They are typically used for critical events as hardware failure. Because it's the critical use, the hardware non-maskable interrupters cannot be ignored. Here in the image we can see there is no mask between CPU and interrupt controllers. Exceptions are Exceptions are a type of interrupters generated with the CPU itself when it encounters an error, a specific conditions during executions. The example for the exceptions are when we divide any new number by zero, a program attempts to be divided by number zero. It's called the exception. Page fault: when a program accesses a part of memory that is not currently in the physical memory. These two are the examples of exceptions. Interrupt handling process. The role of interrupt handling or interrupt service routine ISR is the interrupt handling, also known as the interrupt service routine, is a special function in the operating system that executes in response to an interrupt. Its role is to add address cause of the interrupt and perform the necessary actions to handle it. The steps involved in the interrupt handling are interrupt signs, the interrupt signals, suspend current activity, identify the interrupt, execute ISR, restore state, resume the execution. In this picture, we can clearly see the interrupt handling. The hardware undergoes the interruption. The interrupt controller goes to the processor and then process the interrupts to the kernel. It is the is there an interrupt handler on this line? Then if yes, we have to enter the line RET from int R. If there is no interruption, it goes to no, and then runs all interrupts handlers on this line, and then return to the kernel code. This was interrupted, and in the output we can see if it's interrupted, then we can see that this is interrupted, or if it is not interrupted, then it will be normal. Importance and applications of interrupts. Importance of interrupts in modern computer. Interruptions are essential for efficiency. They allow the computer to focus on executing instructions rather than checking the status of the peripheral devices. Real-time processing. They are enable real-time response to event which is critical in the systems like embedded controllers, automatic systems, and real-time computing applications. Resource management. They help in efficient management and allocation of a system resources. Improve overall system performance. Real-world applications and scenarios. Embedded system in devices like microwave ovens, automatic control systems, and the medical devices. Interruptions are crucial for the timely responses. Operating system. In modern operating systems like Windows, Linux, and Mac OS, interruptions enable multitasking and efficient CPU utilization. Network system. In network system, interrupts handling income data packets and ensure efficient communication. User interface. In user interface, interrupt processor inputs from keyboard, mouse, and other peripherals to provide a Responsive experience. Interrupts play a fundamental role in enabling efficiency, responsive and reliable computer across a wide range of application and devices. And thank you for watching this series of operating system. These are the references where I got all this information about the interruption of operating systems. Thank you once again for watching my video. Like, share and subscribe. Thank you very much. Stay tuned for other videos. Thank you.